Hello Longhorns, this is a short review on Conics sections that I think might be helpful to you if you are struggling with any of the homework practice problems that you've been given. So I want to start with circles, and the first thing we're going to do is, given the center point and the radius, we're going to write the standard form of the equation of the circle and graph the circle. So here we have a center of -3, 2. So I can go ahead and put that point on the graph, -3, 2. And it has a radius of 3. That means that I'm going to go 3 units in each direction from the center, and then from those points I'm going to draw in the circle. And this is free-handed, so it's going to be as round as I can make it, but it's probably not going to be perfect. So there's the circle. Now we just need to write the equation of the circle. And the standard form of the equation of the circle is x minus h squared plus y minus k squared equals r squared, where hk is the center. So all we really need to do is plug in our values for our center and for hk. Well, -3 is our h and 2 is our k. So we're going to plug that in. X minus a -3 minus a -3 squared plus y minus 2 squared equals r squared. Well, r is 3, so 3 squared is 9. And that is our equation of a circle. All right, so the next conic section we're going to look at is a parabola. And we've been given a vertex, directrix, or focus. And we're going to graph the parabola and write its equation in standard form. So the first thing I would like to do is graph this parabola first. Okay, so the first thing I'm going to do is go ahead and plot in the vertex, the focus, and draw the line for the directrix and give the equation for that, and also the equation for the axis of symmetry. Our vertex is at 2, 3, so over 2, up 3, puts it about right here. And our focus is at -1, 3. So -1, up 3, this would be our focus. I'm going to make the focus red colored. And so the directrix, I know, is going to be 3 units away from the vertex in the opposite direction from my focus. So my directrix is going to be right here, and it's going to be perpendicular to the axis of symmetry. And I know my axis of symmetry goes through my focus and my vertex. So this black line here, let me point it for you. This black line here is the axis of symmetry for this parabola. This line here is the directrix, and this is the vertex of the parabola and the focus. The focus is always on the inside of the parabola. So I'm just going to draw a really, just a sketch of this parabola. It's probably not exactly correct, but it's close enough. So the parabola opens to the left. The focus is on the inside of the parabola, and the directrix is on the outside of the parabola. It also forms this 90-degree angle with the axis of symmetry. So I'm going to go ahead and write these equations for the directrix and the axis of symmetry. The directrix is at 1, 2, 3, 4, 5. So the directrix is at x equals 5. And the axis of symmetry is 1, 2, 3 up, so that's going to be y equals 3. So these would be the equations, oops, y equals 3. Let me erase that. So these would be the equations for the two axes, the directrix and the axis of symmetry. Okay, so now we have everything we need. The only other information we're going to need is this distance from the focus to the vertex and from the vertex to the directrix. Now we call that distance P. Okay, so it's p on both sides here. So this distance p is important because it's going to be part of our equation when we write our parabola in standard form. And in our case, p equals a -3. And the reason why p is a -3 is that our parabola is opening to the left. So it's opening in a negative direction. So I'm going to use a value of -3 for my p. And now I'm ready to write my equation. So it's going to look like this. It's going to be either an x minus h squared or a y minus k squared. And since the parabola is opening sideways, it's going to be y minus k squared in this case, equals 4p x minus h. So the 4 is always part of our equation. We leave that in there. So now what I'm going to do is just put my numbers in. Now I know my h is 2 and my k is 3. So I need to be very careful about what I put inside my equation. I don't want to get those backwards. So it's going to be y minus 3, because k is 3, squared equals, and then 4 times p, and we said p was going to be -3 since we're going in the negative direction. So it's going to be -12 x minus h, and h is 2. And that's it. That's how you write the equation for the parabola. Now I just want to say one more thing about the parabola. If this parabola was opening up or down, if it was opening up or down, then we would be putting the x minus h squared first before the equal sign, and then we would be putting the y minus k on the other side of the equal sign multiplied times the 4p. So the direction matters. So if it's opening left or right, it's going to be y squared. If it's opening up or down, it's going to be x squared. All right, so for the ellipse, what we're going to do is we're going to identify the center, the major vertices and the minor vertices, and then we're going to draw our ellipse, and we're also going to determine the length of the major axis and the length of the minor axis. And we're going to write, oh, we already have our equation, so we don't have to write the equation. But if we were given that information, we would be able to write the equation as well. So we're given the equation, and here we're going to graph. So first of all, we identify the center, and the center comes from our HK, again, HK. So 2 is H, and -3 is K. So my center is going to be -2, comma 3. All right, and so notice that the signs change, because this is actually, if I read this the way the formula is written, this is actually x minus a -2, and this is y minus a +3. So this is a -2 and this is a +3. So that's my center. So I'm going to go ahead and plot that in. -2, +3, it's right here. And now I'm going to use these values for A and B down here as my values that I'm going to use for the side lengths. And so I have to take the square root, because this is actually A squared. So this number right here, this 25, this is A squared and this is B squared. So I want to take this A squared and take the square root. So along the X, or along the horizontal side, I'm going to be going to the right 5 units and to the left 5 units. So I'm going to take my vertices, and I'm 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4, 5 to the left. Now those are going to be what I call my major vertices, because this is the longer side of my ellipse. So if my ellipse is horizontal like this one is, then the long side is going to be horizontal. Now I'm going to take the y value, which in this case is the square root of b squared, which is 9. So the square root of 9 is 3. So I'm going to go up 3 and down 3. 1, 2, 3. Okay? And now I'm ready to draw my ellipse. So I'm going to draw my ellipse through those vertices. And now I can identify the major vertices. The major vertices are 1, 2, 3, 4, 5, 6, -7. So let's put this in blue, -7, comma, 3, and +3, 3. So those are the major vertices. The minor vertices are going to be these red ones here. So -2, 1, 2, 3, 4, 5, 6. So I'm going to put those in red. -2, 6. And -2, 0. So those are my, my minor vertices. The length of my major axis is 5 plus 5, which is 10 units. And the length of my minor axis right here, this length right here, is 6. So whenever you're trying to find the length of an axis, really all you need to do is cut whatever your a squared is in half and then double that number. So, I'm sorry, take the square root of a squared and double that number. So the square root of 25 is 5, doubled is 10. The square root of 9 is 3, doubled is 6. So my lengths of my axes are 10 and 6. And that's it. Let's take a look at the hyperbolas next. Okay, so for the hyperbolas, we're given the major vertices, or in this case, we just call them vertices. And from that, we need to find the center. We need to find the length of the transverse axis, the length of A, the length of the conjugate axis, the length of B, and then we can write the equation in standard form and graph it. So we're given the vertices, and that's a starting point. So let's go ahead and draw those in. We're at -5, -4. 1, 2, 3, 4, 5, 1, 2, 3, 4, right here. And we're at -5, 8. So -5, 1, 2, 3, 4, 5, 6, 7, 8. And so now what we need to do is, before we can write the equation, we need to know where the center of our hyperbola is. And so what we're going to do is we're going to find the center between -5, -4, and -5, 8. So what we do is we know that the x value for our center is going to be -5. We know that. So to find the y center, we're going to subtract the two y values and divide by 2. So -4 minus 8 divided by 2. This is going to give us a -12 divided by 2, which equals a -6. Well, we can just take the absolute value of that since we're looking for a distance. So we're actually going to be counting 6 units down or 6 units up from the points we have to get to the center. So I'm going to go ahead and count 1, 2, 3, 4, 5, 6 units. And that puts me right here at this point. So if I added 6 to -4, I would get 2. And if I subtracted 6 from 8, I would get 2. And let's look and see where we're at here. We're at 2. How about that? Okay, so our center of our hyperbola is -5, 2. Now we're ready to find the length of our transverse axis. Now we know that the transverse axis is the axis that goes through the major vertices and the center. So that would be this axis right here. So the length of this axis is 12 units, because 6 plus 6 is 12. And we know that our length from the center to the vertice was 6, because that's what we calculated. Okay, so the length of A is 6. So I know that when I get ready to write my equation, my length for A is 6. That was this length that we found right here. Same thing. All right, so now the length of the conjugate axis is going to be the length that goes side to side. And in this problem, we weren't given the conjugate, but normally we're given the conjugate. So say the conjugate, the length of the conjugate axis, we give you the length of the conjugate axis is 8. So I'm going to give you that information. I'm going to say, well, the length of the conjugate axis is 8. That means that I'm going 4 units to the right and 4 units to the left through my center. And this would be the conjugate axis. The conjugate axis is perpendicular to the transverse axis. Okay, so we need those two axes and we need the center so that we can draw our box. And then we know the length of B is 4 because it's half of 8. 4 on each side. 4 here on this side, on the left 4 units, and on the right 4 units. So the value for B is 4. The value for A is 6. So we're going to need those values when we get ready to write our equation. Okay, so we have enough information now that we can draw our hyperbola. But first, we're going to draw the box. So normally with an ellipse, we would just go ahead and connect these vertices and make a nice oval. But since it's not an ellipse, it's a hyperbola, we need to draw a box instead. So I'm going to draw this box. And since my hyperbola is opening up and down, so how do I know that the hyperbola opens up and down and not sideways? Well, it's going to open along my transverse axis. And my transverse axis is this center axis right here. So these are my vertices for my hyperbola. So that means my hyperbola is going to be opening up and down. So I have my box, and inside the box I also need to draw in my asymptotes because hyperbolas have asymptotes. So in order to get the asymptotes in the right place, we need to draw the box, and then we need to draw in the asymptotes. Now, these asymptotes also have equations, and maybe in a future math class you might have to calculate those, but for us, for right now, we're not doing that. We're just going to graph from the box and the asymptotes. So here comes the first branch. We call these branches. The first branch of the hyperbola. The other branch of the hyperbola is going to come down this way. Now make sure when you're drawing in your hyperbola, I'm drawing mine kind of fat here, make sure when you're drawing in your hyperbola that it does not cross the asymptote. It cannot cross the asymptote. All right, so our parabola is opening up and down along the y-axis. That means that my y squared is going to be first in my equation. So in my equation, I'm going to have y minus k squared minus, because parabolas have a minus, hyperbolas have a minus sign in them, x minus h squared, y minus k, x minus h, and then we're going to have over, and then the branch that's going up and down, this is going to be my a squared along the transverse axis, and b squared is along my conjugate, equals 1. So all of that's going to be equal to 1. Okay, so you know what? I think we forgot something here. Let's go back to my ellipse. Oh, no, we're good. Okay, never mind. All right, so I just want to make sure that you know that both of those equations should be equal to 1. The ellipse equation should be equal to 1, and also the hyperbola. Okay, so you have to have that equal to 1 here. Whoops. Okay, so we're done. We just need to fill in our values for h and k. So the value for this would be y minus, and we have to go with the center now. K is 2, okay? K is not -5, K is 2. So y minus 2 squared minus, and then x plus 5 squared. And now my a squared is going to be the value for, oops, this is not erasing, there we go. The value for a, which we said the value for a was 6. So 6 squared is 36. So this is going to be 36. And the other one is the length of b is 4, so 4 squared is 16. And that's it. Now we have our equation for the hyperbola in standard form. All right, so the last part of this review covers classifying each conic section from general form. You'll have to do this on the test as well. So I just want to go over this really quickly. It's not difficult. All right, so if you have an x squared plus a y squared and the coefficients are the same, as you do in this one right here, if you have an x squared and a y squared, an x squared and a y squared, and you have a plus sign and the coefficients are the same, then this is a circle. So just remember, if it's a plus and the coefficients are the same, it's a circle. If you only have one squared term, either the x is squared or the y is squared, but not both, that's a parabola. If you have an x and a y, if you have an x term that's squared and a y term that's squared, but the coefficients are different, like this one, the coefficients are different, and you have a plus sign. If it has a plus sign, just like the circle has a plus sign, this one has a plus sign too, but the coefficients are different. This one has a coefficient of 1. This one has a coefficient of 3. This makes this an ellipse. This one's an ellipse. Ellipse. Can't write very well there. Ellipse. Okay, and then the last one, where you have, it doesn't matter if the coefficients are the same or not, and this one, they happen to be the same, but they could be different, doesn't matter. If you have an x squared term and a y squared term and a minus sign, it's automatically a hyperbola. It doesn't matter if the coefficients are the same or if they're different. It doesn't matter. If this is a minus sign, it's a hyperbola. And that is all for classifying. And that's it. So hopefully this little bit of a refresher review helps you with graphing and writing equations. And if you need to refer back to it, it's there for you to help you. So if you have any questions, make sure you bring them to class with you, and I will be happy to answer them at the beginning of class.